Now, continuing with the analyze command, I want to look at histograms specifically because they are fairly complex to explain. So back into the same script, I'm actually going to go and connect to a different user, namely my simulation user. And what I'm doing is I'm going to count the rows, which is essentially the same as this picture here. I'm actually counting the rows and grouping them according to this value, in other words 30,001, 50028 on this table. And now I'll re-execute this query and get a more readable result. Obviously the numbers of rows here, 378762 for 30,001, are slightly different. Well, it's not visibly different, but they're different to the original histogram I created because this database is generally fairly active and it has a lot of data continually being added to it. Let's get back to the analyze command before we get off track. So I executed this query, and what I'm going to do is I'm going to go and compute statistics for this table, and this will take quite a while to run because there are a lot of rows. Now what I'm going to do is try to show you the difference when using a histogram. Currently I do not have a histogram. Now I'm going to show you the explain plan generated by the optimizer. In other words, what the optimizer thinks it should do to execute this query. It's basically telling the database that it should execute the query based on an index range scan on this table, and that is its estimated cost. Now let's go and look at a different column and look at the cost on that different column, and as you can see it is identical. And now we'll go and look at this column, which we know from this picture here has very few rows, namely a single row, and we'll execute the estimated cost on that too. And look what we find. We find that the cost for 400,000 rows is 447, and for one row is also 447. For the one row, that is extremely inefficient. The chances are for the 400,000, 30,001 rows, the 447 estimated cost is probably extremely inaccurate. So what I'm going to do is I'm going to analyze this table and compute statistics for a particular column. What this does is effectively creates a histogram on that column. A histogram, much like what's happened here, is that SQL Plus tends to do some odd things on my computer, and it's to do with the recording mechanism. But as you can see here, I've actually analyzed the table. So I'm going to clear the screen and I go back to my script. So now I'm going to run explain plan again for all three of these values: 30,001, 40,003, 5,028, approximately 400,000 rows, somewhere around 175,000, and a single row. So let's run this, and as you can see, the cost for the 400,000 row optimization is almost 1,000. For the middle value of say 175,000 rows is almost the same as the estimate before, but look at the single row, it's now a cost of 3. So basically what we have is a much more accurate measure of how much the optimizer thinks it will cost to execute these three separate queries based on using the histogram. So that's simply showing you that histograms can be very useful in terms of SQL code performance execution based on the optimizer guessing or estimating at how long it will take to execute a query. It's very important that the optimizer gets it right. The more accurate the optimizer is, the more likely the optimizer is going to run the query faster. It should be obvious to see that running that range scan through that index is going to find this particular value much faster